on.
All right. All right, guys. Let's quiet down. Which one's this? This is going to be, this was A.
4D9.
4D9. This one is going to be 6S2. And this one is going to be
4F5.
1, 2, 3, 4, 5. 4F5. Okay, good. Now, this is the deal. You can now identify two of the quantum numbers for that. Okay? This is NLMS. This is what you do. You put a little plus sign and you put the N quantum number there, the L, the M, and the S. Okay, now what I've done is, do you understand that based on that, I can say for this one right here, okay, 5, and what's the quantum number for D? 2, right? Okay. Now, what is the M? Okay. What is the M? You got to draw your 5 circles, just like there for the D. You see that 5 circles for the D?
Mm-hmm.
Yeah.
Now, off-bow rule. What does it say? Who's the off-bow people?
2 electrons per orbital.
Off-bow says 2 electrons per orbital.
No, that's 40.
What is it?
The lowest energy first.
What is it?
The lowest energy first.
Off-bow is the lowest energy first. Okay, right? That's good for hybridization. We don't really need that right now. What's the Pauli exclusion principle?
2 electrons per orbital. And
2 electrons per orbital.
Opposite spin.
With opposite spins.
Yeah.
2 electrons per orbital with opposite spins. What is Hund's rule?
Electrons have orbitals of the same energy in a way that makes the number of electrons with the same spin direction as large as possible.
Right. Okay, so with all that taken together, this is what you do. How many electrons am I going to put into that D? The D orbital, the D energy, the sub-energy level? 6, right? So how do I do it? I go 1, 2, 3, 4, 5. I half fill it. You always half fill. And then you fill, then you go back, right? It has to have opposite spin, right?
Yeah.
Yes? Remember, 1 electron in the orbital means it's plus 1 half, right? The second electron means it's negative 1 half. So this electron right here is plus 1 half. You see that? This electron here, the 6th one, is going to be negative 1 half. You see that? Put it down, negative. Yes? You see that? Okay, now, remember how we labeled these? Remember? What is that orbital position? Isn't it, do you want me to help you? It's negative 2. Negative 2. Do you see that? How many people see that? Raise your hand. Okay. Anybody else? You don't see that it's negative 2? Look at the M quantum number. Look at the position of that far left orbital. Now look down at the number line. What's the number say? Abby? Negative 2, right? Okay. Off camera, Dylan, you want to point that out up there, please? Go up there and point out the position of that orbital. Dylan's from Texas. I said Yankee yesterday or the day before, and she said, what is Yankee? Somebody from Texas doesn't like the word Yankee, trust me. Okay.
I didn't even know they called us that, so.
Okay. Yeah, that's it. Point to it again. Hold your finger there. You see that? Now go down to the number line. Right there. You see that? Negative 2. How many people see it now? Raise your hand. Okay, so what's the M quantum number for that element? What's the M quantum number? Negative 2. What's the S quantum number? Remember, it's the second one, the one that's down. What's it called? Is it, I'll give you a hint. Multiple choice. A, is it positive 1 half, or B, negative 1 half? B, negative 1 half. You get it? Quantum numbers. Excellent. We're going to go off the air. I'm not finished yet. We're going to go off the air. We're going to make 2 more quick videos. 3 minutes each. 2 minutes each. I think I have time. Okay? Yes? All right? Be right back.
903.